Yeah, so this is kind of an interactive talk. It's designed more for uh, someone who's not familiar with Mike said, a broadcast workflow. We're going to take a look at what a modern facility, it's kind of radio centric, but a lot of it is applicable for TV. Um, and most of you, these concepts aren't going to be really new, uh, but uh, I'd ask a couple of questions. If you had to post a job in the last 12 months, some of these buzzwords are probably going to come up. I think a lot of broadcast facilities have had some of their seasoned coworkers decide to retire, and as they as they go off to enjoy their retirement, someone from another side of the organization may be taking their place who's not as familiar with some of these terms. So we'll start taking a look at uh, typical scenarios and IP characteristics that are in modern facilities and broadcast signal chains. So some of the common terms that engineers throw around are, mixing console, and what that does is it just mixes all of the audio um, in a radio or TV station. Um, there's always an automation system of some sort in in TV that switches content. Audio over IP is a audio that's become a very popular way of moving audio around a facility and even sharing audio with other facilities.
You lost your slideshow.
You lost the slideshow.
Yeah, it's just big black with the cursor going across. That's all I'm seeing anyway. And then your desktop behind it.
It looks like Sam took over the screen.
I can't get out of there. Can you take it? How do I get out?
How's that? Can you see
That's
that?
better.
That's better. Yes, thank you.
Yeah, yeah.
Yeah, but I don't have anything now.
You're seeing that?
I'm seeing that now. What do I need to do next?
Okay. So there's simple network management protocol. A lot of our devices in a broadcast facility are controllable via SNMP. A lot of facilities have uplinks for uplinking to satellites. Then there's also a playout server for over the air. And if your station's running HD, there's going to be a thing called an importer or exporter, and that actually is a codec.
Sam, you took the screen again.
There we go. Is it back?
It's back.
But I'm not back.
We'll give it a minute because I think since you took it and gave it back, or he took it back, you got to wait. It should pop up.
So is it back?
Nope.
Yeah, we can see you.
Okay. So in radio, there's HD radio. So in HD radio, HD1 is what is the analog, but
recording in progress.
Many stations have HD2, HD3, or HD4, which can be entirely different programs with different text and graphics. Another term that gets used quite a bit in a modern facility is codec, and that's used to encode or decode to an audio stream over IP. Studio transmitter link, that pretty much what it says. It's a studio to transmitter link. It can be microwave. A lot of people now are moving towards backing up the microwave to fiber. Obviously, there's the transmitter, which produces radio waves or RF, whether it's for FM or AM or TV. At the transmitter site, we refer to coax or RF line, and that connects the transmitter to the next thing, the antenna. And then most facilities have a generator because you do want to be able to maintain broadcast operations during the times when commercial power may not be available. So we'll take a look at the studio. A couple things in the studio that couple buzzwords that get used quite a bit are, there's the catchphrase audio over IP, but that comes in a lot of different flavors. It could be AES 67, it could be Livewire, it could be WheatNet, it could be Dante. A lot of the mixing consoles that are popular in the radio world are Axia, Wheatstone, Lavo, SAS. And automation systems on the radio side tend to be, Wide Orbit, Zeta, Enco, Audio Vault. And so those are all placed usually in the studio. So the mixing console is right there where the operator sits, and the mixing console's really evolved quite a bit because in today's world, it's more of a control surface that's probably fully routable, and you can assign different things based on time of day and the board op that's on. They can have their own custom configurations. And in a lot of facilities, it's really become popular that a studio such as this gets shared amongst several of the signals that they may have. So this might be the morning show for the country station, and it's the midday show for the talk station. It's the afternoon drive for the rock station, and they can call up different configurations on the console. Sometimes there's some local play out still in the studio. Some people still have CD players, DAT machines, stuff like that. Maybe the ability for an announcer to bring in their laptop and plug in. A lot of times there's communication throughout the facility, in an intercom. SIP, is a phone system for putting callers on the air. And what's really becoming popular now is also doing Zoom calls and putting callers on the air. So I said that the mixing console is really more of a control surface. So all of the mixing happens usually in what's called a mix engine or a blade or router. And that can be located in the studio, or it could be located in the TOC. Again, stations utilize a lot of automation, and the automation computers, generally in the studio, there's usually just a KVM where they have the monitor and a keyboard and mouse extended. And for security purposes, the automation system resides on its own isolated network off of not accessible usually to the internet. Although in some instances, they do have remote capabilities. So if you have a remote host in another market or someone working from home, that they can go and voice track, you may have that ability. The other thing that a lot of stations employ is they have the automation system at the studio, and then they may have a server that mimics it up at the transmitter site. So for disaster recovery, so if you have to evacuate your studio, you could still be making money by playing the commercials. And that's become more and more commonplace. A lot of the radio facilities now have a lot of fancy lighting, accent walls, and equipment for doing video podcastings and stuff. So it's not unusual to have the studio looking a lot more like a TV news set, and even under counter lighting and stuff for keeping the hosts. So quite a bit has changed in the facility over the years. And some facilities still do have the ability for the announcer to take a call and record it, and these with a recorder editor that's dedicated on hardware instead of on a software. But some studios still have that. So we'll take a look at the TOC, and it's always evolving. A lot of the infrastructure has changed so that it's top of rack design, a lot less clutter, gives you flexibility of where you're placing equipment. It's usually software manageable, and electrical management. You can see in this picture that this particular facility, they have the cables on the left, the plug mold strips are most likely on a UPS, and you can see that they use red on the left and yellow on the right, and you can see that those servers actually get a feed from both of those panels, so they could have totally separate UPSs. And generally, a TOC is arranged so that it's a single station per rack. So, over to the right of that, the back of the rack, you can kind of see there's some audio processors and then some IP links that would be a typical STL rack. So we'll take a quick look at the infrastructure in a TOC. So like I said, the audio servers generally reside in the TOC, and those can also reside. Like I said, you can have a server up at the transmitter site as well. Color-coded wiring. That's become, broadcast facilities. You have the automation system. You may use one color of Cat5 wire. Your business system, you may use a different one, and that just makes it easier for someone to walk into a TOC and say, "Oh, wait a minute, that's red. That's mission critical," or "It's green. Oh, that's the office network." But you can see that a lot of the modern facilities have a router usually up on the top, and then that controls all of the gear contained within the rack. I was at a facility yesterday visiting with a customer, and they had a situation arise that, as the engineer said, he goes, "Normally I'd be running down to the TOC, but we were in his office, and he just simply called up the piece of gear that he needed in the TOC and made a quick change right from his desk. He didn't even have to walk down the hall." So the TOCs have evolved quite a bit. Also in the TOC is the routing. That's usually where the mix engines, your audio sources, remote broadcast. Very few people use Marties anymore, but a lot of people are using, IP streaming. Your uplinks and downlinks are typically in the TOC. Your intercom and phone system could be also here, because all of the mix engines are generally in the TOC. As I said, the STLs are evolving. A lot of people are now they're maintaining their 950 STL, but they're also augmenting that with AES 192 or Livewire or WheatNet on a fiber feed, even doing full MPX audio over IP. And the beauty of that is that with the IP and having multiple paths to the transmitter site, if you lose one path, a piece of ice falls, takes the feed horn off your 950 or your 6 gig dish, it just hitlessly goes to the fiber backup. Of course, most markets have the Nielsen PPM encoding and some additional audio processing to make that work a little better so that the decoders get it, decode it.
Hey, can we back up there?
Yep.
So the PPM, this will apply as a watermark for television. That is the rating system for those who don't know. And when you're in and somebody's going to probably correct me, the Hampton Roads market is absolutely in a top 50 market. So those who are in a top 50 market, last I heard, maybe it's expanding, getting wider, but I don't think so. They have these little, they look like old pagers that listeners would carry for radio, and then there's set-top boxes, I believe, for the Nielsen community for TV, right? And that is how these ratings for both TV and radio take place. So I just want to clarify that for those who may not know.
Yeah, it also, to expand on that, is that a lot of times this is just showing, 1 PPM encoder, but a lot of times for a radio station, they'll have a PPM encoder for their main signal, a separate one for their streams, so that that Nielsen can actually break it down. Are they listening over the air or on a stream? So.
Yep, and I'll back up even further, because everything that is given as an example now looks radio centric, and while it might be in the examples, everything is 100% relatable to television, just different frequencies for STL links.
Yep.
When it comes to having these remote sites from around the world, they're just different types of links, but it's all the same deal in the TOC, Technical Operations Center. Thanks.
Yep. And usually in the TOC is your off-air receivers, whether it be radio or TV. Make sure that your signal's getting there. You may even be doing logging and recording. I know on the TV side, there's a lot of emphasis on, how the quality of the signal and logging that over a period of time. And then, typically a tuner, hey, I want to listen around the band, see what else is, what my competitors are doing. There may be in there. And like I said, that could be controlled via IP, so that you're in your office and you call up and you stream right to your computer. You don't even have to go down the hall to the TOC. So a lot of changes have happened in the TOC. The other thing is that, this could be a multiple radio station TOC in a couple of racks, where years ago, a radio station may have 10 racks per station, and the consolidation of audio over IP and controlling stuff has kind of consolidated the TOCs. We can't forget our compliance with EAS. That usually resides in the TOC as well. So some additional things that aren't shown in the pictures, are an importer exporter, but it would be just a single rack unit, similar to one of the PPM encoders. There's no audio processing in this particular picture, but that would be their remote control. And usually in the TOC, there's going to be one spot where there's a monitor and a keyboard, so that when you're in the TOC, you can access various devices. So infrastructure at the transmitter site. So everyone knows that there's probably a building up there, And that's the other end of the studio to transmitter link. And you can rest assured there'll probably be a transmitter there, some RF line and antennas, and various backup systems. And then, of course, there's the logistics of getting to the site. This shows a site in winter with a tracked vehicle to get to it. Some sites are like that. Other sites may be like the World Trade Center, where it's an elevator ride to get to your transmitter site. So a lot of sites have quite a bit of difference. So when we take a look at a transmitter site, this happens to be a TV transmitter. It's a liquid cooled. So your transmitter building, some of the things that you want to know about the transmitter building is, how is it cooled? Is it taking outside air with intake fans and exhaust fans, or is it air conditioned, or are your transmitters liquid cooled and you still have a little bit of air conditioning? I was at a couple of mountaintop sites that are often in the clouds, and these sites would just simply take in and filter outside air and blow it through the room during the summer. And with the summit of the mountains in cloud cover, you can imagine what's going into the building, a lot of very damp, moist air. And the patina on the copper on the copper transmission lines at that site looked like they were the same as the transmission lines running up the tower site. A couple of things that IP brings to the table is you can have security cameras and logging and controlling site access for your staff or contractors that need to go there to the site. Some markets actually have, in addition to having a backup at their main site, they may have a second transmitter site that is completely in a different space that could still be on a mountaintop, but it's just a different mountaintop, or it could be on a building in downtown. It's not likely to be full power, but it's just enough to keep the signal on the air over the majority of your listening or viewing audience, and keeping the head ends with a signal. And it tends to be more common in larger markets, but it's something worthwhile looking at if you have a site that is hard to get access to during parts of the year. Obviously, there's going to be a generator, some type of backup facility, backup power at the remote facility. One of the things to remember is that if you have one of these sites that doesn't have access to it 12 months out of the year, and maybe 6 months out of the year that you don't have access, you got to plan ahead and make sure that the generator has enough fuel for what you think could, any outages may be at that site. You want to plan that ahead. Of course, there's the STL, could be 950. A lot of radio is also moving to the LTE cellular, and even some Starlink, working with some stations using Starlink to back up their 950 STLs now. You want to have stream redundancy if you are doing IP with multicast and SRT coding. Most of the transmitters today are going to be solid state. There's still some tube transmitters out there, but the majority of them are solid state. And they can be either liquid or air cooled. They have ramp up settings, and in some facilities, they have what's called an N+1. So if you have multiple, let's say you have 3 signals at a facility, you may only have 1 backup transmitter. They call that the N+1. So that 1 backup transmitter can go on any of the 3 frequencies. And of course, we have monitoring. You're going to definitely want to monitor your over-the-air signal at the site. Remote control, you're going to want to monitor not only the transmitter parameters and antenna, but you're probably going to want to monitor your generator, temperature of the building, whether, the back, someone's opening and closing the doors to the building. There's going to be RF switching at the transmitter site. So very popular these days to have motorized switches to switch between main and auxiliary transmitters and main and auxiliary antennas and dummy loads. And we talked about main and backup antennas. As more and more people share towers with other services, and stations rent out tower space, and there may be times of the day that you've got someone working on your tower and you need to move to an aux antenna at a different elevation on the tower, and that can all be done remotely. So it all gets connected together, and what's going to connect it together usually is going to be an IP connection. So as you walk around your facility, what's the percentage of those devices at a remote site that you can control via IP? And you're going to find that it's going to be, over the years, it's growing and growing and growing. Everything from the generator to your HVAC to all of the broadcast infrastructure. And it's to your benefit to control it via IP, especially if it saves you from having to go to the site. So the key benefits of IP is more control. You've got metering and status commands. And if you're going to use SNMP, most of the manufacturers will provide you what's called a MIN that allows you the remote control to access it. And while a lot of people will always ask me, hey, your transmitters have all of these, graphical user interface. Yeah, it's great that our transmitter does have this graphical user interface. It tells you everything that's going on with the transmitter, but the reality is there's so many other things at a transmitter site that you want to monitor. So you definitely still need a remote control. And you could see as more and more stations have been consolidated, there may be a single master control. So making up these screens so that your operators are able to look at all of multiple sites. They see green is good, yellow bad, red really bad. And it's become really popular too to have weather information put on, especially if you have stations over a large geographic area that you may want to have the weather graphic on the remote control screen as well. So what are the other things in day-to-day operations? A competitor colleague of mine always talks about in his Tuesday Tech Talk that he sometimes does. He talks about preventive maintenance and methods to document that. And a lot of stations used to keep a loose leaf binder with, a log sheet. And whenever I used to go to a transmitter site, you'd fill it out, as you walk around with a loose leaf binder, you check the generator, maybe you run the generator, check, the pressure in your lines and everything. Today, we could all use, our smartphones or iPads or even a laptop computer and put that up in the cloud and using, Google Docs. You could create logging site-specific information that may be at the site, but it's maybe in the cloud. And it includes, all of the typical stuff, trends of the transmitter, pressure of the transmission lines. But the other thing to have for each site is an emergency plan. You probably want to even have this posted at the site. What is the site's 911 address? You can't say, "Hey, I'm on the second building up on Mount Washington. I'm in the second building." Generally, your 911 centers will have an actual specific address for it, and it's important because if for some reason you have an emergency and you need to have 911 come up, you want them to come to the right building. The other thing that you could keep is a master list of contacts, and you could do that in a cloud base. A lot of facilities, sites, are difficult to get to, and you're going to want to have personal protection gear. Some companies allow their employees to climb the tower, and you want to make sure that you have proper gear for whatever you're doing. A lot of times, maintenance of the facility falls on engineering, and you want to make sure you're using the proper tools and using them safely, and pest control. I'll share this little tip with you. One of my customers in New Hampshire, I visited his site about a year ago, one of his transmitter sites, and we opened the door. It smelled like a laundromat. I says, "What's going on, Dirk? Why does it smell like a laundromat?" He says, "Oh, well, I used to have a lot of problems with rodents in this particular site, but I found that dryer sheets tend to keep the rodents away. They don't like the smell of a dryer sheet." And he says, "Every time I visit the site, I renew the dryer sheets." He has them at the bottom of the rack and the top of the rack and in various places. And didn't look like there was many signs of rodents at that site. So sometimes getting to the facility, the remote site is a challenge in itself. And, a lot of mountaintop sites do require, particularly this time of the year in the winter, tracked vehicles. And if you are in charge of one of these sites, do you have a safety plan? Do you let management or someone at the station know, "Hey, I'm going to be going up to this mountaintop and I expect to be there for 2 hours, and then I'm going to be coming down, and if I'm not back by 4 p.m., send out the rescue crew." So you want to make sure that you have a safety plan. So some documentation. This is just a simple Excel spreadsheet that customer shared. He's got the station call letters, whether it's AM, FM, frequency, it's ERP, what the transmitter is, the manufacturer, what the IP address is, if he could control it via SNMP, there's a manual on site. And then he drills down to the antennas. What is the antenna? How old is the antenna? And then it gets into the last visits. What the gate code is, who the alarm system are, what's the electrical service, who's the HVAC, how old is it, who does the snow plowing, who's the tower crew. So you build a database like this so that it allows you to quickly and get this information. And this can be, like I said, in Google Cloud. The other thing about the age is when you're having a meeting with the manager and, you know, wanting to get new equipment and updating some equipment. I mean, it goes in there and you could say, hey, you know, look, the HVAC system is 7 years old. Is there some type of incentive if we upgrade that to something new, more modern? Does the power company give us a rebate to get the energy rating up? So that's pretty much it. Any questions or comments? Is this kind of what you guys do in your day-to-day world?
The floor is open for anyone to ask questions or give input. And this was great, by the way. Thank you very much for taking time to do it. Pretty comprehensive.
Well, thank you. Thank you for having me and for taking time out of your busy day.